Okay, here's what we started off at. We started off with free body diagrams. Again, I am so sorry. I'm human. Always making thousands of mistakes. There was a mistake here. It said Unit 4. It's truly Unit 3. Okay, one more time. It's truly Unit 3. And we started going in through here with free body diagrams. Free body diagrams is a way to isolate and single out one object and all of the other forces that are acting upon that object. We did give an example that if we have a free body diagram of an object, you need to draw, or let's say you don't want to draw the object, you want to draw a box, whatever it is, even if it's a tiny little bitty box, you need to draw it in the orientation that that object is in. So if that object is hanging or is at an angle, hanging at an angle, then you're going to draw the object, or if it was a box, at an angle. If it's flat horizontal, then you're just going to draw it out flat horizontal. Then you're going to add the forces, depending on what physics teacher you have or engineer teacher you have. Some people do break apart friction force from air resistance, but air resistance to me is whenever an object is moving, kind of like when you're walking down the hallways. There is actually friction between you and the air molecules because those air molecules are hitting against your skin. I mean, you feel it on a windy day. I mean, if there's a big gust of wind, you may not feel it when you're just walking down and strolling through the hallway. But it just depends. Now, weight force, which we already did, is Newton's second law, just in case as a quick reminder. And since I have this open up right here, I'm just going to personally go ahead and put weight force. I'm going to draw an arrow. I'm going to write F equals MA, just as a quick reminder for me. F equals MA, because I do see some students, freak out a little bit like, oh my God, I got to take a quiz without the teacher talking. I don't remember what that is. That is also on the formula chart, so don't freak out. F equals MA is on the formula chart. And A is gravity. I'm going to just do another little arrow, a different color, and I'm just going to say right here, gravity is what A is. A little g for gravity, just to give me a reminder, right? Because we have a quiz next week on Tuesday. Then this kind of goes into directions on how to draw a free body diagram. I probably will just fill those in for you. That way you can copy them in when I do scan. I haven't scanned any of the notes yet. I know I haven't. I was waiting until I had a little bit more filled in. But as a quick review of what this is, hey, you're only going to draw that object, number one. You're going to draw it in the orientation that it is in, as in, is it at an angle like this, or is it flat horizontal, the orientation. And number three, you're going to add all of the forces that are being applied. But if the forces have a magnitude, which means a number, like 22GFG, 14FF, then you would put that 22 newtons with that gravitational force if that was the case, if they gave you the magnitude, okay? So that's what the directions right here and right here says, but I just kind of shortcut it for you over here. Then we did a practice problem. We did one practice problem, and then we did a second practice problem. So let's go ahead and let's get to those practice problems and making sure that we have those answered in our notes. I don't see them answered, so let's go ahead and do that. Hopefully you practiced it yesterday, but I know you can get busy too. So right now, let's dedicate our time to make sure our notes are kind of filled in a little bit more. First thing is, we need to find the horizontal and the vertical components, which we did over here. And I drew arrows next to them to kind of give me a clue of which direction overall it's going to move. Was it going to be quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Well, it's going to be over here in quadrant 1, or some people call it northwest. It's going to go towards the north and west in that direction. But knowing this information that we found over here, we know that the horizontal is 570. We wrote it. We know the vertical is going to be 1070. That's pretty cool that we can still make this into a triangle. The other thing that I said, and now I'm saying it again, is, hey, don't forget, Which one is my theta? Well, this is obviously a right angle, so it can't be this one. It's either here or here. Well, to be honest, our theta always touches our x-axis. That's what I'm going to do. We're going to simplify it right now. We're not in, engineering 3, level 3 in aerospace engineer class. So at this moment, we're going to simplify and say that our theta always touches the x-axis, okay? Then we have two equations, right? Two equations. Oh, don't forget, we are actually looking for the direction, which is a theta. We need to make sure that we are in the correct mode, and I'm in degrees, so I'm going to clear that out. Well, I have the A and the O, and so in this situation, since I have an A and an O, I'm going to go ahead and highlight those. Then A and O is the TOA. So I'm going to use the tan of the theta equals the opposite leg, which is 1070, divided by, that's what this is, the O and the A. The tan equals the O divided by the A, and the A is 570. Please don't forget, though, whenever you're actually looking for the theta, you need to make sure that you do this little inverse key. So that for us would be second key tan, which is right here. There it is. It has the inverse that popped up of 1070 divided by 570. I'm going to close parentheses, and I'm just going to do this in one shot. I end up with the theta of 61.9. I'm going to round it up 6 degrees. 61.96 degrees. Now, my other question is, hey, what's the magnitude? This is direction right here, direction. And on this side, they want to know, I'm going to just go ahead and write this in. This is going to be my magnitude, my actual number. But don't forget, numbers have a SI unit. And so for us, let's just easy cheesy, A squared plus B squared equals C squared. So 570 squared plus 1070 squared equals C squared. Alrighty, so for this situation, 570 squared, I'm going to just break it down into 324,900 plus 1070 squared comes out to 1144,900 equals C squared. We know that we need to square root this after we add those two numbers together. So 324900 equals second key square root 800 comes out to the hypotenuse, which is truly, because that's what that is, the H, the hypotenuse, or C, whatever you want to call it, comes out to 12.35. Wait a minute, what's my other units? Newtons. So this unit is also a Newton. So there's both answers question, or both questions answered. All right, it's physics time. Let's dedicate our time to make sure we're doing it correct. Okay. Let's go ahead and answer and make sure that the one below that is also answered, because we got to practice this. I guarantee you this is going to be a quiz day, okay, for next week on Tuesday. All righty. Let's go ahead and I'm going to clear this out, and I'm going to scroll and move up. We actually looked at this earlier this week on Tuesday. So on Tuesday, we talked about this. We went ahead and found our F equals MA, which is weight force, or F sub G, or F sub W. Since I wrote FW, I'm going to put a W right here, and that's going to be 236.03 newtons. We wrote it in our free body diagram. The next part here says, hey, can you find the X and the Y direction? So the X direction would be right here. Again, I said it before, I want to say it again while you're doing the math real quick, is that we do not need a negative value. Now, if you wanted to, you can do, 82 take away 115, but deep down inside, I don't need a negative value. I do need the direction that it's going to go. And I can see that it is overall going to move over to the left. So I'm going to put a little arrow over here because 115 is bigger than 82. Your answer should be 33 newtons. Double check me because that's what I got earlier this week when I did this question. And then the next question over here says, hey, let's look at this one and let's do this in the horizontal direction. And between those two numbers, up is going to win. So up, and I got, double check my number, I got 320, I think 8.97, give or take. Okay, depending on how you round. Okay, I might be wrong, I'm not sure. Take away 236.03. Yep. That's what I got again just right now. So, and that's in the up direction. Now, it's asking you over here, find the magnitude and direction. Or another way to say that is find the net force of this crate, this box that's in some kind of motion. So for me, I'm going to go ahead and do my X and Y axis. And then I need to figure out which quadrant it's going to move to. Right, it's going to go northwest, northeast, southeast, southwest. And this one tells me it's going to go up into the west or to the left. So it's going to move in that direction. When it moves in this direction or this quadrant, it also tells me that this number horizontally right here is 33 newtons. This number vertically right here is 328.97. There we go. And when I see this, I actually see a right angle. On the other side of the right angle is my hypotenuse. And don't forget, for this class, my theta is going to touch the x-axis. So the theta and right angle equals my adjacent leg. Left over is my opposite leg. Okay. I'm looking for two things. I'm looking for the hypotenuse leg, and I'm looking for the theta. I'm just going to go ahead and start off just like I did last time up here. I'm going to look for the theta first, which is SOHCAHTOA. I'm going to call that number 1. SOHCAHTOA. And I can see that I actually have the A leg. I have the O leg. So in that situation, it's going to be the TOA portion that I'm going to use. The tan equals the opposite leg, which is 328.97, divided by the adjacent leg, which is 33, equals, oh, don't forget, when you're looking for the theta, you need to hit the inverse key. So I'm going to hit inverse button. So this is my tan of my theta. Please double check me, but when I did this earlier this week, I got 84.26 degrees. So hopefully that's what you just got right now. Again, depending on, tell me if I'm way off, but that's what we got earlier this week. Now I'm going to do part 2, and let me just box that in for myself. I'm going to call this part 2. Again, you can do SOHCAHTOA, but I'm going to do Pythagorean, whichever one you prefer. But I'm going to say a squared plus b squared equals c squared, or 33 squared plus 328.97 squared equals c squared. Please don't forget to square root it and double check my math. I ended up with a hypotenuse, because that's truly the leg that I'm looking for, or the C, of 330.6 newtons. And I'm just going to box that in. I did it. Again, this is going to be homework number 2, and this is going to be what your quiz is over. So you're going to have a few questions like this. You've got to be able to do this. I'm going to scroll to the middle question that we kind of passed up. Let's go ahead and do it. That way, at least the math for this first part is going to be done. We'll have it to help us answer our homework and have it to look over before we take our quiz. Okay, so let me scroll up. Over here, Roberto and Laura are studying across from each other at a wide table. Laura slides a 2.2 kilogram book to Roberto across the table, right? She slides it. If the net external force acting on the book is 2.6 newtons to the right, what is the book's acceleration? Okay, so I don't know why there's a question mark. Oh, yep, nope. If the net external force acting on the book is 2.6 newtons to the right, I'm going to put a period. What is the acceleration? Question mark A. Okay, well, I do have my force of 2.6. I also have a number here, which is the mass of 2.2. Remember, if we're looking for weight force, then it would be the F equals ma, and A would be gravity. But what did I just say before we even started our notes? Like when I was reviewing, when an object's sitting there and we want to know the weight force, it would be F equals ma, and A would be gravity. But if my object is moving in motion, then we're not talking about gravity. We're talking about the acceleration of that object moving. This actually still is F equals ma. But for this situation, A is not gravity because it is moving. We're not looking for the weight force. We're looking for the acceleration of its movement, not of gravity. So this sometimes becomes a little tricky. So for this situation, they gave us F of 2.6, M of 2.2. I'm just going to fill in the blanks. A is my question mark. Well, Miss Munson, this is not A equals VF minus VI over T. Well, I mean, it could be, but I don't have VI, I don't have VF, and I don't have T. So I'm going to go ahead and still find my A by using this equation. Algebraically, I see that I'm going to divide by 2.2, cancel, divide by 2.2. A comes out to, double check my math, but it's a, put that in, 2.6 divided by 2.2, oops. There we go. 2.6 divided by 2.2 comes out to 1.18 meters per second square. That is still going to be the correct SI unit because that is the correct unit for acceleration. I think that was a good question because I don't want any of us to get confused like, oh, A is VF minus VI over T. Remember, that's the cool thing about physics is that you could still get to the same answer and 3 people could have did it 3 different ways and still got the same answer. All righty, so remember, it's going to be A is something else because we're not looking or concerned about gravity. It's actually moving in the motion. Turn the page when you're ready. All righty, uniform circular motion. Again, this is going to be part of your homework, Unit 3 homework, and it's part of like your videos questions or video worksheet homework. It says here, suppose that you're driving or you're in a car that's driving with the steering wheel turned in such a manner that your car follows a path of a perfect circle with a constant radius. Okay? Remember how last unit we were talking about perfect parabolas? Well, now we're at perfect circles. And earlier this week on Tuesday, I was like, hey, the key word is perfect, perfection. You have to cut that string perfectly. You had to wrap the string around your paper plate perfectly. You had to have perfection. Okay? Well, that's what we're saying over here. That when this object moves around in a circle, it could be, let's say for an example, it's tied off to the end. This radius is the same here, as the same here, as the same here, the same distance all the way around as it moves this perfect circle motion. It says here, and suppose that you drove it, and while you're driving, the speedometer is a constant speed. I don't know, maybe you have that perfect foot force that you're able to keep your speedometer exactly the same of 10 miles per hour because you're in your car. In this type of situation, experiencing this would be what we call uniform circular motion. But we definitely know that all things are not perfect and not uniform. Like things do accelerate, change, are not perfect. Uniform circular motion, it says here, is the motion of an object in a circle with a, bless you, constant speed. Oops. Constant speed. Now I can put a period. Done. But wait a minute. If you're moving in such a manner that your speedometer, it says 10 miles per hour, it never changes, it doesn't go up, it doesn't go down, and you're moving at a perfect circle, that the radius stays the constant distance from the center, are you accelerating? Are you accelerating? Is acceleration occurring? I'm going to put this in a different color, and I'm going to put it in parentheses. Yes, you are accelerating. Because remember, there's 3 ways to accelerate. Number 1, speed up. Number 2, slow down, which I'm not doing. I'm maintaining a constant speed. But number 3 way to accelerate is to change directions. And for an object to turn into a perfect circle, you have to, at every single point, this point, this point, this point, this point, this point, this point, you have to change your direction. So that way you could make a circle. Now, a couple of review words that we already know, but again, though, I need to bring these words back in, is the circumference is the perimeter or the outside of the circle, right? So the circumference would be like this out here, that outside perimeter of the circle. Don't forget, we talked about the word radian. We did earlier this week, and we said the radian is the length of the radius. Oh, those 2 words are different words. They sound like the same, but they're different. On the circumference of a circle. That's what the radius is. I'm sorry, the radian. Or the rad. I'm going to come over here and I'm going to just do a little arrow and I'm going to say a rad. A rad is the same thing as a radian. Rad is just shortcut. Have you ever seen the word radian before this week? You have. On your calculator. Maybe in math class? Right here. Your mode. I don't know if you knew. So now this calculator should make a little bit more sense. You've got degree mode, you got radian mode. Oh, you've been working in radian the majority of your life. You may not have really known what it was or what it means. Hopefully by the time this unit's over, it makes a little bit more sense. But you have been seeing and using that word, degrees and radian. It says here, how many times will a radian fit around 180 degrees? We just did it earlier this week. How many of these rads were you able to fit around the circumference? We call it, say it again. Yep, 3.14. There you go. Or pi. It says here, what do we call this number? We call this number pi. It's called pi. How many times will that radiant length string fit around 360 degrees? I agree 1,000%, 6.28. Or it says here, or wait a minute, it says here, what is the formula for calculating the circumference of the circle? I don't know if you remember it, but it's called 2 pi r. Yeah, 2 pi r. Does that make sense now? Because there's 2 pi's in that circumference of the circle, which is equivalent to the r, which is the radius. Ah, that radius is that radius length, the r, the lowercase r, and 2 pi, because that's 1 pi, that's 2 pi's, wraps around the circumference of radius, which so happens to come out to 6.28. It says here, how does this compare to the number of times the radian will fit around the circumference? It actually is the same. 2 pi r is the same thing as those radians or rads going around the circumference. How many pi rads? Oh, that's a different word. Miss Munson's talking about this word rad or radians, and I heard the word pi, but now she's combining them. How many pi rads are in one full rotation around the circle? 2. This is 1 pi rad. This is 2 pi rads. That's how we call it in physics versus like geometry. Okay, how many radians are in one rotation around a circle? Well, that is 6.28 rads. How many pi rads are in 2 rotations around a circle? Hold up. I just said one rotation or one circle is 2 pi rads. So if I'm going to go around 2 rotations, then that's going to end up being 4 pi rads. How many radians are in 2 complete rotations around a circle? 12.56 rads. Which is equivalent to 4 pi rads, or 12.56 rads. They're the same thing. 4 quarters, $1, same thing. 10 dimes, 4 quarters, $1, they're all the same. We're saying the same thing in different ways, okay? I'm trying to get your brain to be able to transition from geometry that you used in middle school to this pre-cal / physics version that we use. So same thing, just different words. The next one here says, if 2 pi radians fit into one complete rotation, true, around any circle. Remember what I said earlier this week? Did your math teacher say it only was like little circles? No, any circle. How many pi rads would there be in 6 rotations around any size circle. Okay, can I help you out for those of us who are not sure? And if you're like me, I need to visually see it. Help me out, Miss Munson. Okay. How many rotations? 6 rotations. 1 circle, 1 rotation. 2 circles, 2 rotations. 3 circles, 3 rotations. 4 circles, 4 rotations. 5 circles, 5 rotations. 6 circles, 6 rotations. And each circle has how many pi rads? 2 pi rads. 2, 2, 2, 2, 2, 2. How many total? Thank you, sir. 12. How many rads are in 4 pi radians? Oh. Whoa, 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 whoa. What's a pi rad? 1/2 of a circle. 2 pi rads are a complete circle. So 4 pi rads would be that. That is 4 pi rads. How many radians are in 4 pi rads? How many radians are in 1 circle? How many rads are in 1 circle? Here's a half a circle. That 6.28 is the full circle, but they want to know about 4 pi rads, which is 2 circles. So what's my answer? There you go, 12. 12.56. Because it's 2 complete circles. Now, let's go ahead and let's do a little bit of conversions, and then we're going to use your protractor, and then we'll be done, okay? So it says here, we want to convert from degrees to radians. Those 2 equations are going to be on your quiz coming up and next week, and they are on your formula chart. Well, traditionally, they're not on a traditional formula chart for physics. Normally, those are memorized. If you are going to take a pre-cal class here at College of the Mainland, I think your pre-cal teacher has you memorize them. Like there's a couple of math teachers I know, and they have you memorized them. I actually put it on the formula chart since it's not traditionally on the formula chart. I added it myself, and I put it on the side. Here it is over here on the side. I was like, you know what, let's not memorize this. Even though your pre-cal teachers in this building down at the first floor, they're awesome, but they have you memorize it. So if you're converting from angles and degrees to radians, from degrees to radians, you're going to get that number and multiply it by pi over 180. If you're going from rads to degrees, you're going to get that number and multiply it by 180 over pi. For those of us who have had pre-cal, this is probably something that's pretty familiar to you. I'm going to come over here, 225 degrees. I'm going from degrees to radians. That means I'm going to use this one right here at the top. So let me go ahead and type in 225. It says here, multiply it by pi, which is 3.14, divided by 180. It says, how many radians are in 225 degrees? They told me here that it's 3.925. Let me hopefully make sense to you. That's what this is right here. If this is 180 degrees, this is what we call the unit circle in pre-cal. And this is 270 degrees. 225 is going to be about right here at this location. We haven't finished our unit circle yet. Okay? Let me see if I have one that is complete. Dang it. Maybe not. So when we complete this unit circle that we have, some of you in pre-cal, you've seen your unit circle look like this situation. aha. You've seen it in this format, okay? Some of you who have had pre-cal already. In physics, we like it in this format, okay? That's how we like it in physics. Now, if this is 270 and they're asking me 225 degrees, that's going to be about 225. It's about here, 225 degrees. Not quite 4 radians. So 1 radian, 2 radian, 3 radian, a little bit here, and a little bit of this fourth one. So that's where we get 3.925 rad. Yeah, it does. It does. But when I was y'all's age, they didn't have a pi button on calculators. I know. I'm so old. They didn't have a shortcut pi. They didn't. They didn't even have cell phones when I was in high school. That's how old I am. Here we go. Next one. For those of us who are familiar, again, with pre-cal, this is going to be what we call 5 pi over 9. Oh, wait a minute. Again, for those of us who are in pre-cal, it looks something like this. 5 pi over 9. Do you see how this is 1 pi and a full rotation is 2 pi from pre-cal? This is how you look at it in pre-cal. But what is 5 pi over 9 in degrees? Well, let's go ahead and do that. 5 times pi divided by 9. Okay, and I'm going to degrees. Multiply by 180 divided by pi again. Those 2 pi's actually cancel out. So 5 pi over 9, multiply it by 180 over pi. Do you see how these pi's cancel each other out? There you go. 100 degrees. So it actually comes out to 5 times 180 over 9. Okay? Which, give or take 100 degrees, is about over here. Which is about over here. Okay? So, can we turn the page? I think we're okay with this for a moment. Because this is where we're at now. This is going to be part of your homework on homework number 2. This is going to be on your quiz. Okay? So let's go ahead and let's zoom in. I'm going to just skip down to let's go to number 4, and then I'll go to number 1. Number 4, step number 1. When I'm going to do these personally, I grab my protractor, and when I grab my protractor, I need to get my little arrow to extend out. Because look, if I line my protractor up, my little arrow is way down here. I need it over here. So what I'm going to do is I'm going to extend it out. Okay? When I extend it out, personally, I'm just going to put me another little piece of paper just in case. I'm going to come over here and let's extend this out. Line it up on your protractor. Extend it out. There it is. I got my line, I extended it out. I just got an extra piece of paper to the side. Remember, when you line up your protractor, you've got your line here, which lines up with your 0. This line right here and the 90 lines up with your perpendicular 90 degrees. Since it's kind of hard, personally, I'm going to go ahead and I'm going to extend my y-axis. So that way I can line it up a little bit better for myself. Okay, so what did I say earlier this week? When you are working with circle unit, you always start with 0 degrees on the right-hand side and you rotate counterclockwise, because counterclockwise is positive direction in physics. Clockwise is the negative direction. Remember, physics has direction with it. So that means that this object started here and it rotated all the way to here, and it stopped. I'm going to put the word stop. So can we all agree that it's greater than 90 degrees, but less than 180? Okay, so now go ahead and let's do that. Greater than 90 degrees, but less than 180. I get, give or take, line up.
I got 157.
That's pretty darn perfect. I got 156.5. So 157 degrees. Convert that to radians. So if 157 is give or take about here, can you look at your paper plate and see that it's going to be about 2 point something rads? There you go. It's going to be about 2 point something rads. So to go from degrees to radians, it's going to be your 157, multiply it by pi over 180, give or take. And for that situation, you got rad. There you go. How easy cheesy. You are so ready for your homework and your quiz next week. Let's practice one more or so, and then we're going to do a little bit down here, and we're done for the day. Why don't we do the easiest one, number 1? Again, don't forget on number 1, you always start here at 0 degrees. You always rotate counterclockwise, which is the positive direction. You can see I stopped at the 90 degrees. Using my paper plate, I can see that 90 degrees is 1 point something rad, because I did not complete 2 rads. It's somewhere right here. 1 point something. So now when you do that, you can go ahead and say 90. 1.57? They're perfect. Pre-cal is your thing then. There you go. Y'all are ready for pre-cal. You good. Knock out pre-cal, then you're ready for Calculus 1. And College of the Mainland offers Cal 2 math classes. Go for it. All right, so are we good here and here? This is homework number 2. You need a protractor, okay? You need a protractor. Next thing, I'm going to scroll down, and I'm going to go ahead and look at this over here. We've got a couple of questions to look at. Question number 1 talks about a car rotates in a perfect circle around a track 3 times. Again, don't get mad at me, but no joke, I'm a visual person. So 1 time, 2 times, 3 times. How many radians or question mark rads did it transverse? The word transverse means pass through. How many times, how many rads did it pass through? Well, I personally know that a half a circle right here is 3.14 rads. Okay? So there you go. So a full circle is 6.28 rads, 6.28 rads, 6.28 rads, or it equals, there you go. Easy cheesy. You are so ready for pre-cal / physics. Here we go. Next one. Next one says here that you're riding a Ferris wheel that obviously goes in a circle. The car that you are in makes 2.7 complete turns. Okay, not 3 full turns, but 2.7 before the ride comes to a stop. How many radians did you transverse? Question mark, how many rads? So for those of us, again, who are a little bit more on the visual, 1 rotation, 2 rotation, and you did 0.7 rotation. If this is 0 and a half of rotation is 0.5, you went a little bit further, and that's how much you went. That's how far you went. And then you stop. Well, if one circle is 6.28 and two circles is 12.4 or 12.5 something, then 2.7 times, here's how we do this, because we talked about this earlier. 2 pi equals, do you see where this says, look, 2 pi r, 2 pi r? This is my r. My radius is the same thing from geometry as a rad in physics. One more time. A radius in geometry is a rad in physics. So 2.7 times 2 pi equals blank. There you go. Or rotations, however you want to call it. Let's do this again. And then I promise I'll stop talking. You are out fishing with your grandpa over the Christmas break. Oh goodness, I know you can't wait for your Christmas break. When suddenly you catch a fish. Now your grandfather, who always wanted to be a physics teacher, says to you, if it's going to take 408.2 rads to reel in that fish, how many complete rotations did you make? There you go. If we had to go this way to multiply by 2 pi, the opposite is to divide by 2 pi. So 408.2 rads divided by 2 pi is going to equal blank rotations. We're done. We had a pretty intense